Welcome everyone. Today we are looking at 7.5, factoring polynomials. So I know we did factoring last class. Today we're really going to start solving by factoring. So a cool thing with this is the degree of the polynomial helps tell you how many solutions there are going to be. So the degree of a polynomial is the highest degree or the highest exponent of the polynomial. So this degree tells you exactly how many solutions or roots there's going to be. So if you had something with a degree of 3, and that's the highest exponent, that tells me there's going to be 3 solutions. So solving by factoring, we're going to do all the same steps we usually do. So moving all the terms to one side, setting it equal to 0, factoring completely using all of our different strategies, and then solving using the zero product property. So when I look at number 1, I first make sure it's equal to 0, and then I check for the biggest exponent. So that biggest exponent tells me that in the end, I should have 3 solutions. So let's see if we can find those 3 solutions. So we've got an x cubed plus x. First thing we always check for is a GCF. So GCF here could be an x. So if I take out an x, I'm left with an x squared plus 1 equals 0. So remember, you put the GCF on the outside and then you divide by it. So now that I've done that, I can split these up and set them both equal to 0. So x equals 0 is one solution. And then we do x squared plus 1 equals 0. So I would subtract the 1 to the other side. So we get negative 1. Then square root to get rid of the squared. So x equals plus or minus, because we did a square root. And then square root of a negative 1 is 1i, or just I. So that kind of looks like 2 solutions and not 3. However, this means a positive I and a negative I. So right there, that's 2 solutions. So anytime you have a plus or minus, that's giving you 2 solutions. So we got our 3 solutions. So we did it correctly. All right, let's try another one. So first step, make it equal to 0. So I'm going to subtract 3x squared, and there is a like term that I can subtract that from. So we get 4x cubed minus 10x squared equals 0. So once it equals 0, that's when we can start looking at the biggest exponent and deciding how many solutions we have. So looking at this one, our highest exponent is 3, so I know I'm going to have 3 solutions. So 2 terms, they're not perfect, they're not both perfect squares, so let's take out a GCF. So if I look for a GCF here, I could take out 2, and they both have an x squared, so that's the smallest x they have in common. So the 2x squared will come to the outside, and if I divide by that, I'm left with a 2x minus 5 equals 0. So that's when we can split it up. So if I do 2x squared equals 0, and 2x minus 5 equals 0, this one I would add the 5, then divide by 2. So x equals 5 over 2. For the other one, we divide by 2. So x squared equals 0. Square root of 0 is 0. And you can't really do plus or minus. However, we needed 3 solutions, and we only found 2. So a trick is, anytime you take a square root, you should get that plus minus to give you 2 solutions, except with 0. So when you take a square root, 0 is going to have a multiplicity of 2. So that gives me 2 different solutions. So that M2 is how I abbreviate multiplicity of 2, which is going to have an impact on the graph because later this unit we're going to look at graphing. But just know that if you take the square root of a 0, you get 0 with a multiplicity of 2. So we now have 3 solutions. So 2 zeros and a 5 over 2. If you're curious, on a graph, what that's going to mean is that when it hits 0, the parabola is going to bounce. So anytime you have an even multiplicity, you get a parabola that like bounces off that solution or that x-intercept. All right, let's look at another one. So we first got to make it equal 0. So we can add the 9x to the 4th, which we've got a like term for. And we can subtract the 13, which we also have a like term for. So we've got 10x to the 4th, because there's an invisible 1 here, minus 10 equals 0. So once it equals 0, I can look at that, and that tells me I'm going to have 4 solutions this time. GCF. So the two terms, I look for the GCF first, so I could take out a 10. So that'll look like 10 x to the fourth minus 1 equals 0. Okay, this one's kind of new. So, new thing here is I've got two perfect squares. So the reason I know that is if I took the square root of 4, I get an x squared. And a minus sign, which is what you need for difference of squares, and square root of 1 is 1. So this is kind of a new difference of squares because we haven't seen it with an x to the fourth yet. So when you do difference of squares, we get our two sets of parentheses. The first one was the x squared, so it goes first. The second term was the 1, and that's always a plus and a minus. And then that 10 is still hanging out on the outside. So when you split this up, a reminder, if you just have a 10 in the front, if I did 10 equals 0, that doesn't really make sense, so that is not helpful for our solution. But the other two pieces are, so it needs an x involved in order to give us a solution. So here I would subtract the 1, take the square root, so x equals plus or minus 1i, or just I. So that gave us two solutions, a plus or a minus I. Here we've got x squared minus 1 equals 0. So you would add the 1, take the square root, so x would equal plus or minus 1. So right there, we've got four solutions, which is what we needed because we've got a plus or minus I and a plus or minus 1. If it helps you to see it, you could split it up into like I and negative I, 1 and negative 1. So those are our four solutions. All right, let's check out another one. So this one already equals 0. That's a good sign. Whew, this one has a lot of solutions. Look at that. We've got 6 solutions this time. So those numbers look a little bit wild. Let's see if we can find a GCF to take out. So I'm seeing a 2, and the smallest x they all have in common is that x squared. So let's take out a 2x squared. So we'll be left with, we subtract the exponents, so an x to the fourth, divide, subtract the exponents, divide, and subtract the exponents, so no more x. Okay, we saw this last class. So I've got a trinomial, so I'm going to do the x. So I've got negative 24 and negative 5. So negative 8 and positive 3 multiply to negative 24 and add to negative 5. So if you want, you could do splitting the middle term on this, but I think last class we learned the shortcut. So when you have an x to the fourth and there's nothing in front of it, we can split it up into our two sets of parentheses. So what they're going to look like is x to the fourth splits up into x squared and x squared, and then these two terms are what go with them. So a minus 8 and a plus 3. And then the GCF comes with it. If you wanted to do splitting the middle term, you could, but the shortcut does work since the leading coefficient is 1 once we've taken out the GCF. So now we got to do all of our splitting. So 2x squared equals 0. You would divide by 2. X squared equals 0, square root. So again, you can't do plus or minus 0, so we say 0 with a multiplicity of 2. Here we get an x squared minus 8 equals 0. So you would add the 8, take the square root. So x equals plus or minus 2 root 2, which your yellow calculator should tell you. And finally, x squared plus 3 equals 0. You would subtract the 3, take the square root. You can't take the square root of 3, but we are going to do plus or minus. To get rid of the negative, the I comes out, and then we still keep that square root of 3. So we needed 6 solutions. So let's check. So here we had a multiplicity of 2, so that's 2 solutions. Plus or minus 2 solutions, and another plus or minus is 2 solutions. So we did get our 6 solutions. So gold star for us. All right, we've got a couple more. So flip the page. All right, first step needs to equal 0. So we'll subtract the 16. Constants always go last, so we'll have 3x to the fourth minus 2x squared minus 16. So that tells me that I'm going to have 4 solutions, because that's our biggest exponent. GCF. I do not see a GCF. All right, so we are going to dive straight into a trinomial factoring. So we are going to do the x. A times c, 3 times negative 16 gives us a negative 48. And then our b is negative 2. 6 and 8. And the 8 would be negative. So this time our leading coefficient is a 3. So we are going to have to do splitting the middle term. So this is going to look like 3x to the 4th. And then we're splitting up the middle into these two terms. So we've got a plus 6. And then because we're splitting up the x squared, it gets an x squared with it. Minus 8x squared. And then that minus 16. So we do our grouping. So in my first group, the GCF is 3x squared. The second group, my GCF is negative 8. So if I take out the GCFs, we're left with an x squared plus 2. Take out the negative 8 GCF, and I'm left with an x squared plus 2. Perfect. So our parentheses match, so we know we did it right. So our GCFs become one group, so 3x squared minus 8. And our parentheses that match become the other group. And it all equals 0 still. So to end it off, we set them both equal to 0. So 3x squared minus 8 equals 0. You would add the 8, divide by 3. We do like our answers to stay as fractions, typically unless it's a word problem. So I'm going to keep it as a fraction. Take the square root. That does not square root nicely, so I would personally leave it as plus or minus the square root of 8 over 3. So that gave us 2 of our solutions. Here we've got x squared plus 2 equals 0. We would subtract the 2, take the square root, which also isn't super nice, so we're going to do plus or minus. To get out the negative, we do the I, and then square root of 2 does not simplify. So we've got 2 plus or minus groups, which is 4 solutions, so we got it. All right, 3 more. Next one, we need it to equal 0, so let's subtract the x squared and subtract the 1. So minus x squared minus 1. This has an invisible 1, so we've got 5x to the 4th plus 12x squared minus 9 equals 0. So that tells me I've got 4 solutions. We've got a trinomial, so I first check for a GCF. I don't see one. So let's do the x. So a times c is negative 45, b is 12. So this one honestly took me a little while. I don't know the factors of 45 very well, but it's negative 3 and 15. So we're now going to use that to do our splitting the middle term because we've got that 5 in the front. So it'll be 5x to the 4th minus 3x squared plus 15x squared minus 9. So reminder, because that has an x squared, when you split the middle term, it splits into x squareds. So now we do our groups, take out the GCFs. Looks like a 3. So we'll get x squared, 5x squared minus 3. Take out the 3, and we're left with 5x squared minus 3. Perfect. So our parentheses match. So one group is x squared plus 3. The other group is the parentheses that match. So 5x squared minus 3 equals 0. So x squared plus 3 equals 0. We would subtract the 3. So x equals plus or minus I root 3. You would set 5x squared minus 3 equal to 0. So we would add the 3. Divide by 5. It does not divide, so we're going to leave it as a fraction. And then take the square root. So again, that square root isn't very nice, so personally I leave it as plus or minus square root of 3 over 5. We wanted 4 solutions, and we got 4 solutions, so plus minus and another plus minus. All right, we're almost done. 2 more. Perfect, this one equals 0 already. It is 4 terms, and we can't combine anything. So we learned last class, factoring with 4 terms is really just skipping a step, and we're doing grouping. So we can group the first two terms and the last two terms and find our GCFs. So we just found the GCF of each of the groups. So we can take out the x squared, and we're left with x plus 2. So this honestly is faster because we didn't have to do the x part. And we're left with x plus 2. Parentheses match, so we're good to go. So we're left with x squared and a plus 5 and an x plus 2 equals 0. Oh, I forgot to count up our solutions at the beginning. Biggest exponent was 3, so we're looking for 3 solutions. So this one's easy. X equals negative 2 is one solution. Here, our x squared plus 5 equals 0. We would subtract the 5. So x equals plus or minus I root 5. So the plus or minus gives me 2 solutions, and then that negative 2 is the third. So we've got our 3 solutions. All right, last problem. We need to make it equal 0. So let's start moving things. So I'm going to move everything to the left. We change the signs when we do that. So notice we don't have any like terms. So when you write them, we're going to write them in standard form. So it'll go 2x cubed minus 3x squared minus 32x plus 48 equals 0. So we have 4 terms. They're in standard form. So let's try doing our GCFs, so our factoring by grouping. So we've got an x squared here. This one was tough for me, a negative 16. So we've got x squared divided by x squared. We're left with a 2x minus 3. And then that negative 16 comes out, and we're also left with a 2x minus 3. I knew the goal was 2x minus 3, so that helped me figure out that negative 16. So parentheses match, so we're good to go. So x squared minus 16 and 2x minus 3 equals 0. So x squared minus 16 equals 0. I would add the 16, take the square roots. So x equals plus or minus 4, finally a nice one. Here we've got 2x minus 3 equals 0. We would add the 3, divide by 2. So x equals 3 over 2. Well, I think I forgot to check how many solutions, but our goal was 3 solutions. And we got 3 solutions, so plus or minus, and just a 3 over 2. Whew, okay. So I know those take a lot of steps because you've got to like factor, then set it equal to 0. But hopefully the fact that you know how many solutions is helpful, and you can use your factoring strategies to work through this. So good luck, and I hope this was helpful.